In this tutorial, we're going to walk step by step through the process of setting up a procedurally animated, fully playable mech pawn that can be used in games or films. We're going to use locomotor, control rig physics, and blueprints, along with player inputs, to create a fully dynamic character. And then we're going to add some firing effects, along with some explosions and particles. By the end of this tutorial, you should understand enough to create your own character rigs based on these concepts. This tutorial is not a quick walkthrough. We're going to go step by step and try to understand how everything is actually working and coming together rather than just clicking buttons. So let's get started. Okay, so we're going to start with a blank project. I'm using Unreal 5.7, and that's because we're going to be using the physics controls. All right, so I'm going to hit New Project, Blank, and then I'm just going to call it something that makes sense. My project is just going to be called Proc for Procedural Mech for the character we're making. Now, once the project's open and everything's loaded, we're going to do a few things. We need to add some assets and enable some plugins. So let's enable the plugins first. We're going to go Edit, Plugins, and then we're going to search for Control Rig, one word, and we'll see Control Rig Physics. So we'll turn that on. And we're also going to look for Locomotor, and we'll see that there, Experimental. We'll turn that one on. And we'll go over what these actually do later on, but for now, we see the prompt to restart, so we're going to do that. All right, it should boot back up. We can close the plugins window. Now we're going to add 2 asset packs. So this tutorial is going to cover how to add procedural animation to theoretically any kind of character. But for this one, if you want to follow along, you'll be adding these packs. So let's go to Fab. Once it opens, we're going to search for Control Rig Example. And that second one right there is what we're looking for. It should have this thumbnail, and it should say Epic Games as the author. We'll click that and click Add to Project. This is the mech we'll be using. This screenshot is also a good example of the size of our mech. This will come into play later once we're setting it up and trying to create some real weight in its animations. But you can just see that's a person standing next to the mech. Now the next thing we're going to do is search for the Niagara examples. And these just recently came out as of creating this tutorial. You should see this thumbnail right here, and again, Epic Games. Click on that, and click Add to Project. Now this pack is just going to have some explosions, some trails, and impact effects that are just going to let us add a little bit of juice to our rig and really sell the design. Okay, once everything's populated, you should see something like this. I'm going to go back up to the content, and I've got my control rig and my Niagara examples folders. Now something I like to do is actually color these folders so I know where everything is. So the skeletal mesh we're going to be using is here in Mech, Meshes. So you'll see I've got this path down here, but I find it's easy to lose track. So I'm just going to go and set color here to orange, similar to the orange of control rig. And I'm just going to make a little trail down to the actual folder I'm using. In a real project, I'd get rid of all these extra rigs and everything else. Obviously, the structure would be a little bit different. But for now, just to keep things simple, inside the meshes folder, I'm going to right-click on our mesh, create control rig. And it's created right here, but it's got the wrong name. SKM stands for skeletal mesh. So let's replace that and change it to CR for control rig. I'm also just going to put proc for procedural mech in there. And this is just because there's another rig over here that's already been created as part of this examples. We can have a look quickly, but this particular rig is actually quite different to what we're making. This particular rig is more centered around creating animation for linear content. It has some really cool features, and I'd really recommend taking a look into here if you're interested in control rig and want to know how to set up something very structured. especially for animators to use. For now, let's exit out of there. We'll go back to our marked folder in meshes. And I'm just going to open up the skeletal mesh to start with. So this is our character. And you can see on the right are all the bones. If I click the eye up here and go bones, all hierarchy, I can get a good idea of how the legs in particular and the mech really come together. So in essence, what we're actually looking to do is be able to move a target control for this mech in world space and then have the mech walk after that target and figure out where to put its feet and how to move them to create nice, realistic procedural animation. This is going to take quite a few different concepts and combine them all together. But luckily for us, those plugins we enabled earlier will really help us out. So I'm going to close this out and open this control rig I created earlier. So you should see something like this. Now this can be a bit intimidating because you've got our rig we can see over here. And we've got our bones, but then we've got this big empty space. But don't worry, we're going to go through step by step in setting this up. So the first thing we need is that target control we talked about. A control that dictates where the mech wants to go. So if you right click in the rig hierarchy down here on empty space, you can go new element, new control. And we're just going to call this our target underscore CTRL for control. Okay. And once you create that, you'll see this tiny little control down here. Okay. It's a little sphere. Well, that doesn't represent movement very well to me. So let's go over here on the right in the details panel, open shape properties. And if we choose arrow for thick and come back in, we see this nice arrow that kind of represents movement a bit nicer, but it's so tiny. So if we look under the shape section, make sure not under the transform section, under the shape section, we can change the transform of the shape. See, this up here changes the location, rotation, and scale of the control itself, which is used to drive animation and things like that. But the shape is kind of just the representation of it, you know? It could be any shape, it could be any size, but if you move it in space, you're changing the transform. That's something to remember. Okay, so for now, shape transform, we're going to click the lock symbol on scale because we want to change the scale in every direction at once. And we're just going to change this to a multiply of 10. All right, still a bit too small. Let's do maybe 25 or 50. 50 looks nice. Now, part of the reason we're having to use such high numbers here is, like we saw at the start, this mech is giant. If you put a person here, they would barely reach up to the bottom of the mech. So we've got to keep that in mind moving forward because some of these plugins are set up with a human-sized character in mind. It's not going to be an issue, but we've just got to think about the scale of what we're doing as we do it. All right, so now we've got our target. Compile, save. Obviously right now, we move our target and nothing happens because we haven't actually set up any logic. And keep in mind, if you move anything in Control Rig, you can just hit compile and it'll go back to where it was before. One more thing to keep in mind, up the top here, we have snap settings. So these settings are highlighted in blue. So there's location, rotation, and scale. All right, so I'm going to turn these off. Actually, I'm going to turn all of these off and then turn just rotation on and put it to 45 degrees, just so you can see what they do. So now if I rotate, it's not going to rotate at all, and then it'll snap to 45. So it's actually important for now to turn this off. Otherwise, when we're trying to test the rig later, it'll feel more rigid than it actually is. All right, so we've turned our snapping off, we've done that, and we've saved. So we've got our target control, and what do we need next? We need to figure out how to move these feet and when. And as I said, that's quite complex maths. Now, luckily, that locomotor plugin does a lot of this for us. So if we right-click in the graph, search locomotor, we can click that, and we get this node. Now, it has a lot of controls here that are hidden under these arrows, but we'll start from the top and go slowly through them. All right, first up, we've got to run our forward solve into the execute pin. And this is essentially where the logic flow comes from. All right, so now the first thing we set up is the root control. So this is just our target control, and really it should be the only one in there because that's the only one we've created so far. So we set that here. The next thing we want to do is set up the feet. So these arrays are sets of feet. So a human would have one set of feet, a left foot and a right foot. But this mech is going to have two sets. It's going to have its front feet and its back feet. So we've got two sets of feet, and each set has 2 feet in them. So we're going to click pluses. Now we've got one set, our first one, with 2 feet, and our second set with 2 feet. We're going to go into the first set, open up the ankle bones on both. So we're going to start at the top, and we're going to go left to right, top to bottom. And this is important, which order we do this in, because we're going to have to replicate it later. It's also how the underlying formulas work to calculate which foot to lift next. We've added our slots over here, we just have to fill them up. So we're going to say type bone, and now we need to find what is the ankle bone of this mech, because it's not a human, it's not a direct translation. And for your particular mesh, if it's different to this one, or even if you're doing this one, you might have to do some experimenting to figure out what works best for you. I found that this bone right here is the foot front left, seems to work best for me. So I'm going to select that. In the name, I'm going to go foot front left. And really you just need the name here. You don't need to select down here, but when you're searching for it, it can help to visualize that. So next up, I want to do the foot front right over here. Remember, bone, then foot, front, right. So that's my first set of feet. Now I'm going down to my second set. I'm opening up ankle bone. I'm just going to select bone for both. And then I'm going to go foot, back left, and foot, back right. Okay, so far we've just been filling in settings and we're not really understanding, but stick with me. I'll follow through and show you exactly what this is doing after we've set up some basics. So we're going to hit compile, save. And now, if you look closely, we've got these little circles here. Now remember, our mech is giant, so we're not able to see these at the size they really should be. So to get a better size, let's go to the collision radius on each foot bone and set 125 instead of 10. So this is a meter, 1.2 meters instead of 10 centimeters. And now you see the circle covers the whole foot. And this is pretty important because it's also telling the underlying formulas how big these feet are so they don't step on each other and intersect. So we're going to set that for everything here. 125, 125, and 125. Cool. So that's the first part. The second part is these shapes are quite thin and small. So we're going to go down to this debug section at the very bottom, open that, and we can see scale here. Now, if we were to start here and we just did 10 times here, we end up with like very big ugly boxes and all these kind of things. So it's best to do around 50 here, I'd say. And for thickness, maybe make this 5 or 3, just so we can now see these debug shapes. Now that we can see everything going on, we'll compile, save. I can move this central control, remember that we plugged in at the top here, and we'll see something happen. See these little white circles all hopping along? So that's actually the resulting transforms, and it's showing through debug shapes where these feet are aiming for. Now you'll notice a few things wrong here. Firstly, it's making very small steps. So if we open these movement settings here, we can see a few settings we're going to need to change. Firstly, minimum step length of 10 centimeters. That's way too small for a mech this big. Let's start with 100. Let's also change the speed max. Let's multiply that by 5, so that's 400 from 80, and 250 for the minimum. So this is the minimum speed it moves at and the maximum. We're going to leave acceleration and deceleration because we actually want something a bit slower. So even though We're scaling these ones up. Having a lower acceleration and deceleration in this case is going to help us. And now if I move this, you'll notice those circles are taking bigger and bigger steps. But obviously our rig's not moving yet. Don't worry, we'll get there. All right, so I'm going to compile and save. And before I tweak anything else here, I want to actually get this thing moving. So if you remember at the start, we needed our target. We needed to figure out where the transforms for the feet are. And we also need to set up the IK rig. Now, what's an IK rig? I'm just going to briefly show on another rig we have here the difference between an IK and an FK setup. So IK and FK have been a thing in animation for a very, very long time. And essentially they represent different ways to animate something. Some things are very naturally animated with FK and other things are very naturally animated with IK. But what does it stand for? So FK is forward kinematics and IK is inverse kinematics. FK is essentially, if I wanted to move this leg, I would bend each bone on that leg into the pose that I wanted it, right? But this has a problem, especially for things like feet and hands, where as humans, we're not really thinking in terms of rotating our thighs a certain angle and then our calves and then our foot. We think we want to put our foot on a position. So that's where IK comes in, and it essentially takes the end bone and animates up the chain from there. We worry about where the foot is going to be, and everything else compensates. For example, here in this rig of this little guy, he has an IK foot control. So I can click here, press W to bring up the transform, and I can move this foot, and you see how everything up the chain animates. Okay, so now we understand what IK is, but how does it affect our mech? Well, we have the transforms for where the feet are meant to go, and we want to use those to calculate how the animation on the entire rig should look. So we're going to be using something called full body IK. We're going to connect the execute node, and then we're going to go and we're going to set the root. Now it's important to note, root control over here is for a control. This root is referring to the bone root, and it actually means a pelvis or hips. It's looking for where all the legs connect to. So we've got to figure out what bone that is. If we scroll up to the top over here, we can see root, and it might be natural to look here, but this is not what we're after. We're actually after the next one up, this base, because you'll see if I minimize some of these, each set of legs connects straight into this base. And the reason we don't want this root control and we want the base is we actually want the movement of the legs and the target control to affect the pelvis, hips, or base of the character. So we want that to move around as well. So over in root, we're going to select base here. Remember, if you need to find something and you've got a long list, you can also search. Okay, so we've got that, but we also need effectors. Now these effectors are our feet. So if I click add array element, it's going to add a effector. So I need 4 of these, 1 for each foot. So 1, 2, 3, 4. It's important we populate it in the same order we set up the foot sets. So we've got our front set of feet and our back set, and we go left, right, left, right. So we're going to start with foot, front, left, foot, front, right, foot, back left, foot, back right. All right, and you might notice something weird happening over here, but this is actually showing us exactly what we'd expect. This full body IK is using these effectors to calculate the position of the rig. We've told it, hey, you start at the base, pelvis, and each effector is on these feet. But currently there's no transform, so it's essentially using world 0 and dragging all the feet there and calculating the pose from there. So that's where these come in. So we've calculated the transforms through the locomotor. We just have to grab them out. So if I drag that out here and use at, I can get the element at this index in the array. So this is returning an array, multiple results of transforms. So index 0 is the first result, meaning foot, front, 1, left. Okay? So I'm plugging that straight in there. And then I copy. I'm just going to make more of these. And we count up. 1, 2, and 3. Because we've got to remember, in programming, you start counting at 0. And that's the first index. All right, so we're just going to plug the array into each of these. And now plug these back in. So we've got index 0. Then we've got index 1. We've got index 2. And we've got index 3 for a total of 4 different results. Now you can see everything's back to how it started. I'm going to hit compile and save. Now if I move this, I get very rigid results. So hit compile again to reset everything. And I've got to go back down here and open up the section pelvis. And I've got to allocate that pelvis bone. So we're using the same one up here. We could have done this before, but it's no harm doing it now. So I've hit base here, compile. So now that's plugged in. We've still got plenty of other things we have to improve. So if I move this along, you might notice both of the left legs move at the same time, and then both of the right legs move, which looks very strange. So the way we fix this is going into our feet setup. So here's a trick. If you hold down Shift and left click one of these arrows that expand things out, it'll shrink that pin, but it'll also shrink every pin underneath it. So I'm opening my foot sets, opening my 0 index and my 1 index, and then I'm going to change this thing called a phase offset, and I'll show you what exactly we're changing in a second. But if I change this to 0.75, you'll now see I get much nicer movement, where the sets of legs are offset. So what is this? Why does it work? Why does 0.75 the magical one? Well, to figure out how this works, I'm going to refer to this documentation, and I'll link this below the tutorial because it goes very in depth in the whole setup and use of the locomotor node. And honestly, it's probably your best resource for getting exactly what you want and creating a really stylized look particular to your rig. I strongly encourage you to check it out. But if we scroll down here, we can see this representation of the cyclic phase function. And this is what's driving the legs. And it's what allows us to have 2 legs, 4 legs, 6 legs, however many legs we want. Essentially, what it starts out as when we have a set of feet, in this example, 2 feet, the phase offset starts at 0 and 0.5. It gets split between the legs, right? So our left foot goes here, and when this value comes around, that's when this triggers. And our right foot is here, halfway around. So when that goes around, that triggers. So that creates that offset for left, right, when you're walking. However, when we add another set, it's also using this same set, which is why we're seeing both left legs go forward and both right legs. So what we do is we offset it by 0.75, which means go 3/4 around to here. So now our front left foot goes here and moves, and our front right foot goes halfway, but our back left foot goes here, and our back right foot goes here. So as this ticks around, those feet move. Now, this is really good to know if you're looking at setting up a different amount of legs. Maybe you've got 3 legs, and you need to tune things like this and really understand how this was working under the hood. So back to our rig. We can see it's moving, however, it's kind of just sliding along the ground. These legs aren't picking up. So let's fix that. I'm going to minimize the footsteps. And for now, I'm going to minimize the pelvis as well and the debug. And I'm going to minimize the movement. So now we can open up stepping and focus on these settings. we have a few different settings that change how it animates through the air, which are going to be important and are really good to tweak later. But for now, let's look at the step height. If we're making a step and we're moving 6 centimeters above the ground, that is really tiny for something this big. So let's try something bigger, like 100. Now you can see he lifts his feet off the ground. Let's try maybe 200. Cool. Now he's very stumpy, which I like. Okay, but he's still moving really quickly. You can see how quick these legs snap up and down. If we close stepping and go back up to movement, we can look here at the phase speed min and phase speed max. Now this is how fast that line is going around the circle, triggering all the feet to move. So at its smaller speed, it's going around the circle 1 time per second, and at the most speed, it's going around 4 times per second. So let's go something like 2 and 0.5. So now when he's going his absolute slowest, he's going 0.5 speed around that circle, so 1 circle every 2 seconds. And when he's going his quickest, he's going twice around. And you can play with this until you get what you like. Okay, and with that, we've got our basic rig. Now we're going to come back and we're going to tune things up and tweak a lot of what's happening here. But for now, let's set this up so we can actually walk around an environment with this rig. And that way we'll know what we want to change more accurately, because that's going to be our test case scenario. So I'm going to close this out. I'm going to go back up to content. I'm going to go File, New Level, and I'm just going to create a basic level that we can walk around in. I'm going to file, save current level as. I'm going to add a new folder called Maps. And I'm just going to call this Character Test Map. And hit save. Now, in order to get a character working, there's a few things we need to do. Firstly, we're going to set up the blueprint of the character. So if I right click here, go new folder, I'm just going to call it blueprints. And I'm just going to quickly set this color to blue for blueprints. All right. And then I'm going to go right click, a new blueprint class, and I want to create a pawn. We choose a pawn so that it can receive input from a player. I'm just going to call it pawn proc mech, and I'm going to open that up. Now we're just going to create a very basic pawn. So if we go over here, I'm going to go add, I want to add a collision capsule. So I'm just going to add that and make it the root. Then I want to add a skeletal mesh. So this is going to be our mech. So over here, click the skeletal mesh asset, change it to skm_mech. Okay. And now I just need these to line up. Okay, so I want my capsule half height to be maybe 200 and my radius to be 100 for now. Obviously, this isn't covering the whole mech, and we wouldn't use this for a lot of things, but for the purposes of this tutorial, this is okay. I'm also just going to set the thickness to something like 10, and I'm going to search for hidden and turn off hidden in game and ensure that it's visible. This just means when we're playing in the game, we can see this capsule. Okay, and now our capsule's quite far off the ground, so we're just going to change our perspective to one of the orthographic perspectives, and that way we can grab our mesh and pull it down until the transform is on the bottom of that capsule. Compile and save. All right, and now we're going to go back to perspective. Cool. Okay, so now we need to add our control rig. So we're going to add control rig, and this is our component. We're going to select it over here on the right in the details panel, open it up, and we're going to look for our mech. So here we are, control rig, proc mech. That's the one we made before. We're going to click that. And you should see it jump into position here. Now you notice it's offset because we dragged our skeletal mesh down before, so I'm just going to actually parent it to the skeletal mesh and then reset the location. Compile, save. Okay, so the mesh is there, the control rig is there, but we need something to look through the camera, and we also need a way to actually move the pawn. Not the mesh or the control rig, the pawn itself, because then the control rig will interpolate to where we move it to. Okay, so let's start with how we're going to be viewing this character. So to do that, we're going to need a spring arm, and we're going to need a camera. So the camera attaches to the spring arm, and let's attach the spring arm to the skeletal mesh. And we're going to use a specific bone. So over here on the details panel, we're going to hit the folder button, and we're going to attach it to that base or pelvis bone, just to start with. All right, we're going to hit compile. And if I swing around here, you can see what's happening. So this red line represents the spring arm, and the camera is at the end of it. And what's going to happen is as the mech moves, the spring arm is attached, and the end of the spring arm will smoothly interpolate to where it needs to be. But right now, it's very close, and it's pointed at the back. So what we're going to do is quickly reset the location. That'll just mean its center is now at the hip location. We're going to rotate it 90 degrees, and because I've got my snap off, it's not going to quite hit there. So I'm just going to do roughly, and then up here in the details, I'm going to say 90. Then I'm going to extend the length of this arm. So let's try 1500. Ooh, that's way too long, isn't it? So maybe around 800? Or 1200. Okay, and that'll give us a good starting position. We can tune this later. I'm going to compile, save. Now when we spawn in, we'll be looking through that camera. But we won't be able to move the character, right? So we need a movement component. And for this, I'm just going to be using a simple floating pawn movement. If you were creating a character for a video game, you'd want something quite a bit more complicated. But it would go beyond the scope of this tutorial. So for now, we're keeping it simple. We're going to search for floating pawn movement. And this is essentially a stripped down character movement component that doesn't take into account a lot of things. So it's very optimal to run, and it's got a lot less settings to play with. So over here, I'm just going to quickly change the max speed to represent what we had roughly in our control rig. Let's say 400. And let's put that acceleration down just to 40 and deceleration to 80, just for the moment. We can come back and tune this later. I'm going to compile and save. Okay, so now we've got this movement component, but we don't actually have a way to tell it to move yet. That's what we've got to code. So if I go over to my event graph, I'm going to want to create input. But to do that, I need to use Unreal Engine's enhanced input. So we're going to do this quickly. This is not the focus of the tutorial. But if you want, you can research this later and learn it more in depth. I'm going to go to my content. I'm going to make a new folder called input. Now, if I right click here, I can actually go down to the input section and see what options there are. So I don't need force feedback. I need input actions and input mapping context. And essentially how this works, we want an input mapping context, which is a list of how every input, for example, clicking your spacebar, maps to a particular action. So that then later on we can map that action to some functionality in our character. For example, if we wanted a left mouse button to fire the cannon in our character, we would have to create an input action. Maybe we would call it fire cannon. We would assign that into an input mapping context, and then we would say, okay, the left mouse button results in the action fire. And then in our blueprint, we could add that action and have the logic come from that event for the firing. The reason it's set up like this is so that you can easily swap out different keys to do different things on different platforms. So on an Xbox, I could have it be a trigger button. On the PC, it might be the mouse button, and it would still do the same actions I want it to. So let's start with the input mapping context, our list of mappings. So we're going to call it IMC, input mapping context, and we're just going to call it default. Okay, if I open that up and I drag it to the side here, And we can see there's no mappings there right now. So I'm going to add an action mapping. This is where we would put those mappings. But first we need to have these actions to map keys to. So what actions do we need? Well, we want to be able to move our character. We want to be able to fire that big cannon. And we also want to be able to look around and aim. So that's 3 different actions. So I'm going to right click, input action, IA for input action, underscore, movement. Let's add those other 2. Right click, input action, IA, look, or aim, whichever you prefer. Right click, input action, IA, fire, cannon. All right, and you see they've got this little star. That means they're not saved. So I'm just going to go File, Save All, or Control-Shift-S, and it's good to just do that regularly. All right, now that I've got that, I can actually drag in my movement into here. So what do I actually want this to output in my event graph? Well, for movement, I need at least a 2D axis, right? I need to know if I'm going forward, back, left, or right. So I actually need to go preferably into the input action itself and change the value type. So by default, it's set to digital bool. And this is essentially, it's a Boolean. So it's essentially, is it on or off? And that works great for something like firing a cannon if I'm just clicking the mouse. But for something with movement where, I could be holding my trigger a little to the right and a little bit forward, we need something more complex. So we click that and we change it to axis 2D, vector 2D. And we're going to save. I'm going to do the same for look, because I can look left and right and up and down. Axis 2D, vector 2D. But fire cannon can stay the same. I'm going to go back to the mapping context. And this is the bit that can be a bit difficult to wrap your head around. And it's just good to look at existing setups and then understand why they're doing it that way. So for the movement, I'm going to just stick with the keyboard for now. And I'm going to have 4 different keys. And you probably guessed, I'm going to have W, A, S, and D. Now it's good to pair these together. So W and S represent the same axis if you think about it. One is forward in the positive and one is back in the negative. So I'm going to click here and go W. I could also click on this drop down here and search for S and then scroll down and find it here. But you'll probably find it's a lot easier to click on this keyboard and then click the key you want. All right, so now I've got all of those, but I have to tell them which axis they're operating on. All right, before we just go ahead and assign things, let's take a beat to make sure we're understanding how this is set up, because it's really easy to copy existing structures or follow this tutorial, but not actually understand what you're doing. And when you run into an issue later on, it's more difficult to solve. So essentially for this, as I said, we've got the 2D vector. So that's our X and our Y. Y in this case is going to be our forward direction and our back, and our X is going to be our right and our left. So it's easiest to start with D, because this is actually in the positive X, okay? A is going to be in the negative X, S in the negative Y, and W in the positive Y. That's pretty simple, right? But now let's look at this. We're going to start at D, okay? Just because it's the simplest. In our case, we actually don't have to do anything to D. By default, it's acting in the first dimension of the vector, and it's meant to be positive. So it's already returning a value that is positive in the X, okay? But the A, the next one up our list, is also returning that exact same value, as well as the S, as well as the W. So we've got to change them. So the A, we actually want it to return -1 when it's held, rather than +1, because it's going in the negative X axis. So what we actually do here is we go in and we add a modifier and we negate it. Now for the next set, we're still operating in the X axis. So we've got to swap it to operate in the Y axis, because we want W to be forward and S to be back in the Y axis, but not the X. So what we've got to do in that case is do something called swizzle input axis values. A very weird name for something that's essentially moving the value from the first dimension to the second. Now you'll see the order here is actually what we already want. And if you hover over, it swaps the X and the Y axis, because normally the order is X, Y, Z, and it's just saying, okay, instead of it being XYZ, it's now YXZ. So that W value is moving from the first position to the second. Now we've got a positive Y value. And the S, we just have to do both of these things at once, okay? So we're going to add two things. We're going to swizzle to move it into the Y value. And we're going to negate because we actually want it in the negative. Okay, and now we save that. So if I do our trick, hold shift, minimize, and open again, we've just got the movement isolated there. And that should be good. But let's go up and set up the aiming and the firing while we're here. They're a lot simpler, I promise. Okay, so for the mapping, we're just going to add another. It's going to be IA look. And you can see I've foolishly named it the same as something that's coming in from Fab, probably from the control rig examples. But if you see in the thumbnail, it says Fab. This one doesn't. That's mine. Another way to tell is if I hover over it, that path that you see just below in the details says game input. That's the folder I put it in. Whereas this says game Niagara examples gallery inputs. Okay, so we're going to click our one we created. Maybe you've thought of a better name than IA look. And in this case, we can try clicking this, but it's not really going to work because we want it to be when we move our mouse. So this is a case where we have to go in and search for mouse. And what we want is the mouse XY 2D axis. So it's actually already a mapping that relates to the whole 2D axis. We don't have to mess around making it up like WASD to put everything together. But we do have to change one thing. We have to go into modifiers and we have to negate the Y. And we just have to do this because this is the way a mouse works. When we move forward in the mouse, we actually expect to look up instead of down. So we negate it. If you're using a controller analog stick to look, you typically don't do this. All right, and the last mapping we're going to do is fire cannon. Okay, and this one's even simpler. We just click it and we left mouse, and that's assigned. Cool. So now we have those mappings set up. If I Control Shift S, I'm going to full screen everything. So now I can actually add this mapping context to the character to basically say, hey, this is your list of controls and all the options that you have for input. So we're going to do it at begin play. Typically, you might want to set this up in a player controller, especially for online play. But if you're just learning, you're following this tutorial, you're messing around, I wouldn't worry about that stuff at the moment. It's much better to get things going and tackle things one at a time. So we're going to right click here and we're going to set our list of controls. So we're going to search for enhanced input and scroll down. And we want the get enhanced input local player subsystem. And this is what manages the input for local players on this machine. So I'm going to drag out from here and I'm going to say add mapping context. And I'm going to connect that to my begin play. So when the game starts playing, we're going to add our mapping context. And again, I've used the same as another, but we can see fab here, not fab here. So I'm going to click that. And I don't really need to change these values for this. So now when we begin play, this mapping context gets added, which essentially means the game is looking and listening for these inputs to come through, for me clicking my mouse, my WASD, but it's still not going to do anything just yet, okay? Let's just delete these. Okay, now we've got our mapping context being added, but we need to add functionality so that the pawn knows what to do when these input actions are activated and these events are processed. So we're going to right click, search IA, input action, underscore, movement, and we select this top one here, the action event, not the action value, the action event. Okay, and we get 2 pins that are exposed automatically, and these are actually just what we need. So triggered is executed every tick that WAS or D is pressed down, and the action value is that 2D vector that we've got, essentially telling us where in this 2D vector we are. If we're holding down W and D, we're up here. No keys, we're in the middle. You know what I mean. So we're going to actually process these two values separately. So I'm going to break these out. And I'm going to process my A and D first. So that's my left and right. So I want to add movement input. And the scale of that is going to be in the X, whether it's -1 to 1. But for the world direction, I'm actually going to use the control rotation, which represents what the player controller is doing and looking at. Okay, and this is so that we don't end up just going along the one axis, so always going in the X or whatever without being able to turn and look and move in a different direction. So to do that, I'm going to get control rotation. And I need to convert this into a vector, but I also need to do one more thing. I don't want it so that when I look up in the sky and hold W, I actually move up into the sky or anything like that, obviously. So I'm going to right click and split this. And then I'm going to go here and say get right vector. Okay, and the reason I do this is because I'm operating in that x-axis. If y is forward, the x is to the right. So it's essentially saying turn this vector relative to this value. So it's essentially saying what is the vector relative to this area where 1 is to the right along this axis and -1 is along here. Okay? And we're going to, as we said before, ensure the pitch is 0, but take everything else. And this represents our x value. Now we'll do the y. So I'm going to get control rotation. I'm going to split that. And for the forward and back, I'm going to make it even simpler because I know that I definitely don't even need the roll. So I'm going to go here, get forward vector, not right vector, forward, split that. And I'm just going to take that yaw because that's all I really care about. And then I'm going to add movement input. Okay, so I drag that over. I've got my direction. And then this is the multiplier. If it's +1, I'm moving along that direction. -1, I'm moving against it. So already that should allow us to move forward and back. I think it's about time we tested something. So I'm going to close the other tabs and minimize this and click play. Now, it's not doing what I expected. And why is that? If I look on the right, it's actually spawning in the default pawn. I haven't told it to spawn in my particular pawn. So I'm going to go over to blueprints, right click, go blueprint class, and I'm just going to choose game mode base. So GM_Mech is what I'm going to call it. And that'll just allow me to go over to world settings. If you don't see that down here, you might have to go window, world settings. And I'm going to do a game mode override, GM Mech, expand that out, and I'm happy with everything else because I'm not taking advantage of the player controller class at the moment. But I do want to just change the pawn to my pawn proc mech. All right, and if we click play, we can see so many things wrong. Okay, and this is why it's good to test things as you go. If I go W and S, it's moving the wrong direction. A and D, we can see it's all offset. It's halfway through the floor. The rig isn't moving as we'd like, but we haven't set that up yet. All right, so first things first. For the movement to work correctly, we really need to set up an ability to look around. So I'm going to right click IA look. And this is where it's handy to make unique names, which I haven't done. But if you hover over here, you can see the path for which one is correct. IA input action input. So that's the one I put in that folder. Click there. And for this one, I'm just going to drag out from triggered, add controller your input. And that's that first one. And this is saying for the moving my mouse left and right, it's going to look around in this kind of direction. And then I'm going to add controller pitch input. And then so when I'm moving my mouse forward and back, it changes the pitch. Okay. I'm going to compile and save. Okay, so that's set up, but now I need it so that when I move my mouse, it actually changes the control rotation. So I'm going to click on the spring arm and say use pawn control rotation. I'm going to compile, save. And if you go up here and you're working on one monitor, like I am for this tutorial, you can click new editor window and it'll come up with a little window on top, which can be handy for doing this. And my mouse moves where I want, and if I look over to the left and I hold W, I'm going to move in that direction. So that's the first step. That's what we want. All right, so we want to use our control rig that we made because right now it's looking pretty ugly and it's just sliding around. So we're going to click our control rig and we're going to hook it up to an event. So if you scroll all the way down, you'll see this on any component with exposed events. All of the events are listed down here. For this particular one, we want on pre-initialize. So this event runs when the control rig itself is initialized. And this is where we're going to map our skeletal mesh to the rig. So right now, this skeletal mesh and this rig are actually two separate things. So we're going to drag out add mapped skeletal mesh. Okay. And our target is going to be our component, which is our control rig component that comes out of this event. And our skeletal mesh is going to be this. So if I drag that in here, hook that in, that's set up. So that's the output. Now if I compile, save, and play, I can move and the rig will start moving. Now this is a bit slow for my taste, so I'm going to go into our floating pawn movement. I'm going to set the acceleration to something like 200 and the deceleration to 300. Let's see how that looks. Okay, so now it's moving around, and that's something we can tweak depending on how we feel we want things. But we still got this issue where it's halfway through the floor, so let's get that addressed now. So the reason it's halfway through the floor, if we go and we look at our map, we're using this player start, and this player start is built for a roughly 6 foot high or 2 meter high character. You can see its location is set to 92, which is the half height of the Unreal mannequin. Now an easy fix for this is if I go in and I go to capsule, and if I scroll down, I can see in the collision, it's set to overlap all dynamics. So it's not actually blocking anything. It's happily sitting inside that floor. So I'm going to change it to pawn. I'm going to compile, save, hit play. And now you'll see it adjusts the location correctly when I spawn it. Okay, so our capsule's really just visualizing where our mech is. And you can see if I change my rotation, I look this way and then hold W, I'm going to move in that direction, which is what the player wants. Now, there's a lot of things we've got to change with how it rotates and how it moves around, but this is our first step and it's working. Okay, now that we've got our mech moving around and we can see our control rig working, we can jump back in and start iterating and improving things. So the next thing we're going to work on is having this mech turn to face the direction that the player is looking. So we're going to go into the control rig, follow our trail, back here, and open up control rig proc mech. So before we continue, we want to identify how exactly we want this mech to rotate. Now there's a few ways to go about it. I've chosen to go one way, and that's what the tutorial will focus on. But you should be able to use what you learn here to try some different things. What I'm talking about is the idea of there being a forward direction and a back direction, i.e. this Y direction always being forward and this always being back, and then the mech's rotation actually rotating so that the front of the mech here always faces along there. And this is perfectly valid. I've decided to go with the alternate approach, which is the turret instead turning to face wherever the player is looking, and the mech legs acting as if they can move in any direction and not worrying about where the front or back of the mech is. And this will make more sense as we go along. But because I've made this decision, I won't be applying any rotation to this base control. I'll be adding a new one, which simply rotates this turret in a 360 angle to look where the player looks. And this is really highlights the strength of procedural animation in that I don't necessarily need a forward direction. The procedural rig will compensate for whatever I choose. Now, in order to get this working, I'm going to need another control. I'm going to need to take in the player rotation in the yaw, meaning their rotation looking around on this plane. And I also want the pitch so they can change this cannon to look up and down. So to do that, I'm going to create a new control. I'm going to call it aiming control. And I'm going to parent it to the target control. I'm also going to scale it up so we can see it. And change the shape to a two-sided arrow. And make it green so it's distinguished from the other one. I'm also just going to bump it up in the location so that it's a bit easier to make out. So now I want to take my rotation from my character, take it through this control, and have it affect the base of this turret, which just controls the top turning point. I could go through and I could make a different setup, change the bone directly, or create a new IK if I wanted something more reactive. But what I'm actually going to do is I'm going to take advantage of this full body IK node and just add another effector. And since this bone, the turret base, also connects to the base, it should help solve all of this all together as one pose, rather than going through separate calculations with separate influences. So I'm going to add that bone, turret underscore base, to here. And you'll see it dives down, and that's because our transform again is 0. So we're going to have to supply it with a transform. Now, if we just supply it directly with the player rotation, we're going to get this result where the turret is instantly snapping to the sensitivity of the player, and it's going to feel really unnatural. So what we're actually going to do is create a spring interpolation between where it is and where we want it to be. So the first thing we want to do is get the current transform of this turret base. So if I drag this in here and I say get bone, this is already going to populate with the type bone, the bone name, the space, and output my transform. So from this, I actually want to keep the translation and scale the same, okay? But I do want to change the rotation, right? So that's what we're going to be smoothing between the two options. So let's make our end result so we know what we're making. So to do that, we're going to drag off our transform over here and say make. And we're going to just keep the translation, which is the location, and the scale the same, okay? Okay, now we want to get the target rotation, okay? So that's going to be our aiming control. So we're going to get that. We don't care about anything except for the rotation. So this is the rotation where the player will be looking, and this is the rotation it's currently at. Now these are expressed as quaternions right now. Quaternions and Eulers are two different ways of expressing a rotation. You can look into it. It's a little bit tricky to wrap your head around. We won't go too in depth here, but needless to say, Euler is probably what you're used to if you've used packages like Unreal or other DCCs, whereas quaternions are a different way of expressing that can be harder for us to wrap our head around, but they do allow us to get around some tricky technical issues, but we won't be needing them for this particular calculation. So we're going to take them into Eulers and then convert it back to quaternions. So I'm going to drag off here and just search to Euler. Okay. And I'm going to copy paste that and just have the same one here. So now I've got these expressed in a way we're more familiar with, the XYZ. And remember, for this particular one, I'm just looking to rotate this turret, okay? And I only want to rotate it in the yaw along this axis. I'm not interested in changing the other axes. So really, I want to keep the X, which is the roll, and the Y, which is the pitch, the same, but I want to take the yaw from our player rotation. So what I'm going to do is I'm going to create a spring interpolate node. I'm going to drag off of here for the target and say from Euler. So we can convert from our Euler back to our quaternion. We're just going to make a bit more space for ourselves. Okay. And I'm just going to select what I want. Exactly what we said before. I'm keeping the X and Y the same from the bone, but I'm taking in this new Z. And now this spring interpolate node interpolates from the current to the target value. So our current value will be our current bone value. Okay, and now I'm going to plug this result into this rotation. Let's neaten this up a little bit. Now I should be able to select this control here and rotate it, and you'll see the turret rotate. So this is what we want. However, you can notice it's rotating very, very quickly. It's interpolating very fast. So we want to look here at the spring interpolate, and this controls not only how much strength there is in changing the rotation, but how much damping it is. And this is actually really fun to play with, so I encourage you to do that. The strength value, I'm going to lower because I want it to feel like this is really heavy and it's hard to move around, right? So if I put it to 0.5 and I rotate it really quickly, I get that delay as it has to build up that momentum and power to move this heavy bit of machinery. Now, critical dampening can be very cool. Essentially, if you hover over any of these, by the way, you can see some description about what they do. Now, critical damping is going to allow us to add a little bit of a spring to it. If I set this to something crazy low, you can see what I mean. At 0.1, it's going to be very, very bouncy. So see, I've let go long ago, but it's bouncing and oscillating past that point. If I set it to 0.9, I get it following quite closely. But I still get a little bit of something in there. All right, so now we've got our turret moving, but we don't yet have it hooked up to the player controller. So we're going to hop back to our blueprint and jump in here. We need to set our target control rotation in our control rig to the value coming in from the pawn control rotation. And the way we're going to do that is through another event. So if we click on control rig, scroll down on the right, we can see on pre-forwards solve. I'm going to click that. So this event occurs just before this graph. So it's the perfect time for us to set our values so that they can be taken into account right here. Okay, so what we're going to do, we're going to drag out, this is our control rig component. I'm going to say set control rotator. And for this, we're going to need the name of our control. So we go back to here, take note, aiming control, whatever you've got, make sure you copy exactly the name and the capitals. Okay, I'm going to split this struct pin. I'm going to get control rotation. And I'm going to split this. And then I'm just going to map the pitch here and the yaw here. And the reason I do it this way is just so we don't have any roll values. There's no roll being applied, but it just makes it easier for anyone who's looking at this graph to understand, okay, I don't need to worry about this value. All right, so if we click play now, we're going to notice something. Yes, the rotation does change, but it's offset by 90 degrees. So why is this? If we look at our rig, we can see everything is facing along the y-axis with y is forward, which is pretty common for characters. But for control rotations, everything is done with x is forward. So when we're taking in our control rotation, the yaw that we're getting is based on x being forward, meaning the rotation that we're going to set this to is going to be along this direction offset by 90 degrees instead of this way. So there's a few different ways to go around it. We're going to do a bit of a quick and dirty way. So all we're going to do is we're going to offset the yaw. So we're going to add minus 90 and plug that into the yaw. And when we click play, we're going to see that turret points along that axis. Now this will more clearly show what I was talking about before, where we can turn in any direction, hold W, and we'll start walking in that direction. This is quite different to the alternative discussed where you would turn and the mech would turn around. Okay, so now things are basically working. There's still a few things I'd like to change though. For one, I don't like that you can pitch all the way up and down. Okay, so now we've got the yaw working. The next thing we're going to work on is the pitch. I want to be able to move up and down and have the pitch of this cannon change with my movement. I also want to avoid this situation where I'm clipping close to the ground and going above. So to do that, I'm actually going to go over to spring arm and I'm going to turn off inherit pitch. This is just going to mean that the spring arm now doesn't move up and down, so it's locked in position. This is a choice you can make if you want, or you might want to just limit things. This is what I'm going with for now. I'm also just going to bring the spring arm up so it's higher. And I'm going to bring the camera up as well and angle it slightly down. So let's say 200. And minus 10. Let's see what that looks like. I'm going to bring it even higher. And I'm also just going to offset it slightly to the side. Too high, so let's say 350. And these are the kind of things you'll tweak as you figure out exactly what type of game you want and how you want your controls to work. So now I want to change it so that the pitch of my controller changes the pitch of this cannon. And to do that, we're going to do something very similar to what we did before. But I'm just going to show you a different approach. So we're not going to use the full body IK. Instead, we're going to set the rotation of this bone directly afterwards. And the reason is this particular rotation is going to be used for our player to aim their weapon. So just like before, we're going to get our bone. It has the rotation that we already want. So we're going to get that to Euler. Then we're going to get our control. To Euler from that rotation. And for this particular one, we want to just take the pitch, which is located in the Y, and keep the other rotations the same. So we're going to use a spring interpolate node, but instead of using it on the whole rotation, I'm going to show you that you can just use this on float values as well. So we're going to take the value here. We're going to say spring interp. We're going to take our current value and plug it in there. So we're going from our current bone value to our target control value. I'm just going to change these numbers to change how the spring works. And then I'm going to make a from Euler node. Now we want the X to stay the same, the Z to stay the same, and we want to take the resulting spring from the Y. All right, and now I'm just going to set the rotation on this. So I'm going to make sure I get the right bone, drag that out, set rotation, plug it in, and plug the quaternion in as well. Cool. Okay, so now let's preview it. So you might notice when we move up and down, we get some really weird behavior. So this is actually what's called gimbal locking. And it means the rotation in some direction has locked in a way that makes when you rotate it, it reacts quite strangely. So to fix this, we're actually just going to use the rotation order. So if you look at all these nodes, they've got a particular rotation order. And this is essentially the order that the rotation's happening. So it's Z, Y, and X. So it'll rotate this way, then it'll rotate this way, and then it'll rotate this way. And if we change this to make our Y happen earlier, we should avoid some of these issues. Now when we preview, you should see it going straight up and down, because the Y rotation is applied first and there's no gimbal locking occurring. All right, but we do get some weirdness, right? Like we can rotate way too far down and way too far up where this is getting stretched. So we probably want to limit the rotation a bit, maybe between here and here at the most extreme. All right, so we're just going to do a quick and dirty way to clamp these values. I don't recommend this for a production rig, but for what we're doing, where we're prototyping, trying to figure out what this rig should do and what it should look like, this is fine. We can come back and clean this up later. We're just going to clamp the values directly in here. And we've got to set the min and max values. Now, there's a few different ways you can figure this out, but the most simple is just guessing in here and seeing what happens. So we see if we change it to 15 degrees, it actually bends down. So we already know we don't want it a positive, we want a negative. We probably want the range to start here at the absolute lowest point. And then for the highest, around minus 45 looks alright, especially from the back camera. So we'll set our minimum value to the smallest amount, minus 45, and our maximum to 0. Now when we compile, save, and try again, we can see that our cannon stays between those ranges. All right, so if you're working on this kind of rig, this is where you'd spend a lot of your time, going back and forth, changing settings, making sure everything feels how you want it to do. Right now, I've gone for something that's kind of slow to accelerate, slow to move. It's got semi-mechanical controls where you're not really looking up into the sky, you're holding this. The next thing I want to do is add the ability to fire. Now that's going to come with a few things. I want to fire a projectile. I want that projectile to explode. I want to have effects. And I want, most importantly of all, for the firing of the cannon to affect the rest of the rig. I want it to feel the physics of it firing. So that's what we're going to focus on next. All right, so in order to achieve this, I'm going to need to set up the physics control rig aspect. Now, for physics control rig to be set up, I need to go and set up something for every single bone I want to simulate physics. And doing this manually is just too much of a hassle. So we're going to do it somewhat procedurally. We're going to create lists of bones, then procedurally go through and apply the physics settings we want to each of those bones. What this is going to allow us to do, apart from speeding up our initial process, is make changes much easier in the future. So, we're going to want to create a construction event. So this is what happens when the rig is set up. And it's going to allow us to create values that we can reference later on in the rig. So the first thing we're going to do is make some arrays. These arrays are going to represent each chain of physics in our rig. So if I go over here to my blueprint, I can create some variables. I'm going to add one. I'm going to call this FL underscore physics bones, meaning forward left physics bones. I'm going to change the type to rig element key. And then I'm going to change the variable type up here to array. Compile, save. So I'm actually going to need one of these for each leg. So I'm just going to quickly copy and paste. I'm going to change this to forward right physics bones. Change this to BL for back left physics bones. Change this. B right physics bones. Cool. And now I want two more. So I'm going to add a new one. This one is going to be called Cannon physics bones, and it's going to represent the physics bones I want as part of this turret. And then I'm going to add one last one called base physics bones, which is just going to represent the core physics bones, most notably the base bone. All right, so if I drag this in, I go set front left physics bones, and I plug that in. I get an array here, and I could go in and I could add each element of this array, go to my hierarchy, find the leg, add front leg here, leg front 01, and go in, but that's very tedious, right? So I'm going to clear that array. A much easier way is to say get chain. And what this is going to do is it's going to get every bone between the start bone and the end bone. So I'm going to say leg base front left. And you can see over here, that's the first bone below our base. And I'm going to go all the way down to our foot front left. Okay? And we're including the start and we're including the end. And this has just added all those bones to an array for us so we can plug it into there. Much easier than doing it ourselves. So now we just have to do this for each of these arrays. All right, so once you've got all of those leg chains in there, just hit compile, save. And now essentially this is populating those 4 arrays so we can use them later on the rig. We're also just going to do the cannon and the base. For the cannon, our chain is going to be quite a bit shorter. We're just going from the turret base to the main gun. And the base physics bone is just going to be our base bone. So we've got this set up. Let's quickly label it. And put it to the side there. So now I've got all these in separate arrays that are very easy to isolate and create different settings for and everything else if I so choose. But I'd like to combine them all together into one big one that I can use to set up my physics. So I'm just going to add another array. I'm going to call it all underscore physics bones. I'm going to drag it here. And the first thing I'm actually going to do is reset. So this is going to just remove all the elements. And this is just in case anything funky happens. We don't want to keep adding bones to the list or anything like that. Let's add a sequence node here so we can keep things a little more neat. So it'll go through, do A, and then it's going to do B. We're clearing out everything from the array. Then we're going to drag each of these in. And we're going to use a union node, which is just going to combine the arrays. So the first thing we're going to do, we clear the array and we combine this now empty array with this one here. And we should be good to just use the output here from here on. So union, here, we're going to add the next chain, and so on. All right, and so now we've got right here all of the arrays together. We just want to use that to set our all physics bone value. We're gonna label this, combine arrays, and move it over. So now that we've done all this setup, we're ready to actually create the physics bones. So we're gonna add another output. And we're going to spawn, firstly, our physics solver. For now, we're just going to set the owner to the bone root and leave it there. All right, so this is going to be our solver, but we actually need those physics bodies. So we've made this array, all physics bones, and for each one of these, so 4 each, we're going to go through and we're going to go spawn physics body. Okay, hook it up to here and hit compile. Now you'll see nothing happens because we're creating these things, but we're not actually ticking physics inside control rig just yet. So we're going to go down here to our forward solve, and I'm just going to section these out by creating a sequence, connecting A to the locomotor. For B, we're going to step the physics solver. We've got to change it to the same root as we used to create the solver. And then you'll see everything over here starts working. Now, obviously we've got a few issues. Firstly, it's falling through the floor. So let's go back up. We're going to change our solver settings. And we're going to change the world collision type to all. Now when I hit compile, now it falls on the floor. But obviously there's a lot wrong here. Each of these bodies are simulating physics, but they're doing it independently. They're not actually constrained to each other. So in our setup, we're going to spawn the physics body, but then we're going to go in and spawn joints between physics bodies and their parent. All right, so we're going to right click here, spawn physics joint. We're going to plug in the execute. I'm going to use that same element from our array to spawn the joint. So now when we compile and save, it's still collapsing, but it's staying together a lot better. So even though we haven't selected a parent, luckily for us, it's automatically set up so that it's looking at the next bone above itself in the hierarchy and connecting to that. Okay, but how do we stop it collapsing like this? Well, what we want is physics controls, and they kind of act as a guide. They're going to pull our location or our rotation into position, and we can set the strength of these to kind of simulate muscles or mechanical joints. So we're going to drag off our same element, and we're going to spawn physics control. And we're going to tick on use parent body. Now if we compile, it's still going to collapse. And that's because there's not enough force at play yet. So we want to open up the control data. And this is where we get to decide how to affect the rig. Okay, so let's start off with angular strength. If we set this to something like 3 and hit compile, we can see it's trying to keep the angle of these the same. The linear strength is going to try and work towards that position. Now, because we've clicked use parent body, we're creating these physics control, these kind of guides in the space of the parent joint. So essentially, it's trying to stick closely to its target location relative to the parent. But we can also put something in here with similar settings, turn off parent body, and let's perhaps remove the angular strength and make sure we hook in the owner. And now we've got what is a world space physics control. Okay, let's disconnect here so we can get a better look. This is operating in world space, and you can see these joints are trying to stick to wherever the world space is. They don't really care where the bones above them are, but if we combine them together, we can actually get some pretty nice results. So I find setting linear strength in world space works pretty nicely. And you kind of want to tweak this till you get something that you enjoy. But by the end of it, you should be able to move your mech around, and you just see we get all this extra motion for free. Now, some things to pay attention to. If you change this linear damping ratio, for example, let's set all of these to 0.5. Much like that spring earlier, we'll get a very bouncy looking set of physics where it's overshooting, oscillating between positions, and then coming to rest. All right, and if we increase the strength, let's say from 3 angular strength to 12, it's going to have a lot more force in pushing to follow this rotation. You can see here that the feet are sliding a little bit. And if we wanted to fix that, we could change our damping back and maybe even increase the strength. And now the feet are sticking much closer to the target location. So this is where you can get creative, mess around, try and figure out what you like, and get something that matches your character more closely. Don't forget to keep jumping back into the test level and simulating to see how it actually plays out when you're moving around and controlling this character. Alright, so here are 3 fixes for things I noticed while I was testing. The first is, you might notice while playing a little bit of jitteriness, where it feels like either the mech or the capsule is going back and forth. So this is happening because of the order that things are updating in. So right now, if we click on the skeletal mesh, and we look in the details panel, we can search tick, and we can see the tick group is set to pre-physics. So this means that the skeletal mesh, the thing we're actually viewing, is updating before physics takes place. So then after it updates its visuals and we can see it, then the physics is occurring, control rig is updating, and then it's getting applied, but we've already rendered the skeletal mesh at that point in that position. So what we want to do is we want to go and set it to post physics. It might be a bit hard to see in the recording, but it should be much smoother for you after doing that. The next thing I want to change is something I set up very roughly before, which to be honest is not good enough. You'll notice the character starts looking to its left. This is actually the direction it should start in. Now, this is because our character has been brought in and its forward direction I've left facing down Y. Really, with a character, I should change its forward direction to face down X. So I'm going to go in, I'm just going to change the rotation to -90, and the way you can tell is the 2 front legs are a bit closer together and a bit longer. Now we also have to go back, and where we've set up the control rotation into the rotator, just remove the offset and just leave the yaw as is. Now when we compile and save, we should now be facing the correct direction at the start. And the last thing I want to do is just get rid of this capsule. You can turn it back on when you're testing and when you're trying to figure out the acceleration and kind of movement you want for your character, but right now it's a bit distracting. So I'm going to go to capsule, I'm going to go to hidden in game and turn that on. So now compile, save, and when I click play, my capsule's gone and everything is aligned a bit better. Okay, now we're ready to move on to something a bit funner. I want to add the ability to fire that cannon, and I want to add lots of cool effects and reactions from the physics rig and a projectile with an explosion as well. So to do this, we're going to go back up where we have our other inputs, just to keep our graph a bit clean. I'm going to right click here and search for fire cannon. And this is that event we made before in the IMC and bound to left mouse. So for this one, I don't want to use triggered because that'll cause, when I hold down left click, continuous firing, bam, 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 every tick. I either want started to happen as soon as I start to click the mouse or completed to happen when I release. I'm going to go with completed. To keep things structured, I'm going to show you a workflow I sometimes do for logic when I know exactly what I want to happen, but I haven't created that logic yet. So there's a few different things that need to happen when we fire the cannon. We need the effects to spawn, and we also need our projectile to spawn, which will have its own logic inside it. we're going to go in and we're going to create a custom event called Trigger Cannon Cosmetics. And we're also going to create one called Spawn Cannon Shell. Okay? And even though these are both empty right now, I'm going to put them in here. So Trigger Cannon Cosmetics and Spawn Cannon Shell. In this way we can see the structure we're going to have and it can help us plan things out. Okay, so for the Cannon Cosmetics, the first thing I'm actually going to do is go into the viewport and then add a Niagara particle system component. So this is going to be used to spawn the muzzle flash. So I'm going to grab it, drag it onto the skeletal mesh to attach it, and then over here, just like the camera, we're going to search for the socket. So if we search and we click Cannon 3, it's going to snap to this endpoint. But you'll see it's offset because when we dragged it onto the skeletal mesh, it took on that 90-degree rotation and that vertical offset from the mesh. So all we have to do is just reset these values here and we should be good to go. So now the system is in there. We can choose the effect we want to use. So I'm going to search here. And if I search muzzle, I can see muzzle flash. So I'm going to click that. So now I want to figure out how big does this have to be and what are the correct settings to use. And I want to do that in relation to the mech, right? But if I change a value over here to get it to trigger, the control rig is also resetting. So there's this handy thing down here under Niagara Utilities called debug. So I can click that. And if I click loop, it'll trigger and it'll continuously go through and trigger. Now, if I go in and I lock the scale and change this to something bigger, because I want a bigger flash, you'll notice it becomes bigger, but the particles also become further apart and it starts to look very strange. A lot of Niagara effects aren't set up to use scale and scale with that because they've got their own internal parameters that control that. So we should reset scale. Now, luckily for us, the artist that created this effect has actually exposed a parameter called global scale. So we don't have to go in Niagara and change anything. We can click global scale and change it to something we like. So 5 seems pretty good to me. Now there's other controls here. You might notice there's a shell coming off here. You can control what angle it comes off. You can control the side flash, whether it has smoke, sparks, and what the colors are. We won't touch any of that, but feel free to change that up. Go back to our Niagara debugger, close that out. We're going to turn auto activate off. Compile and save. So now we have this emitter at this location ready to go. Let's quickly call it ns underscore muzzle flash, just so we know what it is when we're looking at it in the outliner. If we go back to event graph, we can now drag this in, and on Trigger Cannon Cosmetics, we can simply do activate and drag that on there. Compile, save, and now if we play, every time we left click, the flash comes up. The next step is to actually animate our cannon when we fire it. We want this big barrel to rock back into the base and preferably affect the physics of the rig. So to do that, we're going to go back into our control rig. In another workflow, you might want to actually make this an animation, but we're going to try and keep everything procedural here. All right. So I'm going to add another pin off of our forward solve. I'm going to drag out cannon 1. I'm going to get that bone. I'm also going to drag it out and I'm going to set that bone. Okay. I'm going to change both the spaces to local space. And I'm going to expand out here. And for the translation, I want a spring interpolate node. So this is just so it's a smooth animation like we've used before. Okay, and now our current value is going to be here. And I want to keep my scale and my rotation the same. I'm just using the spring interp on the location. Now we have to figure out our target. Where do we want this barrel to be? So if I drag out cannon again, I can get bone. This time I want to use initial and local space. Initial is going to get the value of that bone in the initial pose of the rig. So it's always going to be the same. So I can use that and then subtract 400 in local space and set that as my target. Okay, and now when I plug this in, you should see the barrel come all the way back. Okay, so it's coming a bit too far back. Remember, this is going to be very quick, so a little bit of error is okay, but maybe 350 would be good. But now it's stuck there, right? Because it's running through this and it's setting the transform to this target, which is static, and this current location, which is static. So I want it when I click the mouse to change the offset to this, but when the mouse isn't clicked, for it to just take the initial value like this, right? But I still want it to run through this spring to give it some nice animation and interpolation. So to do that, I'm going to create a new animation channel. I don't need a control where I can move it around and everything else because I just want this to be a on or off switch. So I'm going to right click here, new element, new animation channel. I'm going to go and change it to a bool, and I'm just going to change it to fire underscore CHNL. Okay? And I've got it currently parented to aiming control, and I'm happy to leave it there, but it's important to note for now. I'm going to compile and save. Now I can drag this in, and I can say get animation channel, and it's going to get the value of this channel, whether it's on or off. Now we can now set this in our pawn, so hook it up to the firing. But before we do that, let's set it up. So when I'm firing, I want this offset to be the value. But when I'm not firing, I want this initial translation to be the value. So I'm going to drag off here, search select, drag the index into our bool. And when it's 0 or false, not firing, I want this. And when it's true, or 1, and it is firing, I want that. And then I plug that into the target. Okay? And now you'll see the cannon go out there. But if I change the fire channel current value to true, it'll go between the two. Okay, let's compile and save that. Now we need to actually animate this from the pawn. So we're going to go back into the blueprint, event graph. We drag in our control rig and we say set control bool. And we need to make sure we get the name exactly right. So CHNL with capitals. And we want, when we fire the cannon, for the value to be true. Now if we play, and I go in here, when I click left mouse, it fires back, but it doesn't reset, right? Because that value is staying as true. So I'm just gonna keep it simple and add a delay after this of a very small amount of time, let's say 0.1, and copy paste this and set this to false, okay? So now we fire and set that bool to true and instantly set it back to false. And we get it going back and forth. Right? But you might notice it doesn't go all the way. It's a bit sluggish. We probably want more power when it's going down and less when it's going back. So I'm going to use this same setup for the switch. down here. And I'm going to use this to control the strength on the interpolate node. I'm going to set critical damping to 0.9 so we get a little bit of bounciness. But for the strength, I'm going to drag a select. And when it's not firing, I want it to be 4, like it was before. But when it is firing, I want to try something like 12. So it's a lot more powerful. So we plug that in. All right, so that's all right. You can tweak it more if you want. But I'm still not really feeling the impact, right? So I want the whole rig to react every time I click this. The physics of the rig should move a bit. So the next step is to add another branch here, right? But things are getting a bit messy. So I'm going to just show you something really quick. You can just grab all these nodes, right click on the node over here, and say collapse to function. And if I go over to my blueprint, I could just rename this to Canon animation. And now all that is happening in there. I can always open this up, make any changes I need to, but things are a bit easier to read. And you can do this with anything you want. All right, so I'm going to add another pin, grab our fire channel that we had before, and create a branch. So we'll do one thing if we're firing, and we'll do another if we're not. So if we're not firing, we just want the controls to be reset with no offset. So we'll do that first. So we're going to go set physics control target. Okay, and we just need to open this up. And for our item, we want the main gun. And we're just going to do physics control. Now for the next one, we're going to copy paste. And for this, we're just going to do... So then we're going to copy paste. And for this one, we're going to do the turret base. Okay, and this is also going to be physics control. So we can just leave that now. The information here is just the offsets. And we're leaving everything with no offset when it's not firing. Okay, so we'll put that down there. When it is firing, we want these same things up here. So go copy paste, but we want to adjust the translation of the target. All right, so if you go over here to the rig hierarchy, top left, click that button and click show components, you'll see a lot more things populate in here. So I've got the physics body, the physics control, the physics joint, and another physics control. Because remember, we've got our world space and our second local space. We're only interested in the world space right now. So I'm going to drag in the physics control for the turret base over here. And I'm going to drag in the physics control for the main gun over here. Okay? If I expand the component out, I'm only interested in control target. I'm going to subtract. Expand this out. I just want the gun to go 150 in the x-axis to be pushed back that amount. And for the turret base, the bigger part behind it, I want it to also be pushed but less. So I'm going to change the control target, subtract. And for this one, its bone is set up slightly differently, so I need to do it in the y-axis. I'm just going to do 75 and set that as the target position. Let's clean things up a little bit. So now, when we fire, we set these offsets back into the mesh on the physics controls. And when we're not firing, we set them back to the starting position. Compile, save. Now when you left click, you should see it jolts it back like that. I feel like the mech is reacting to the shot, but the camera is not really feeling it. So let's add camera shake. In our trigger Canon cosmetics, we're just going to make space before the delay and add camera shake here. So I'm going to right click, play camera shake. Okay, and for this to work, we actually need to assign a camera shake. Now there's some in here, like this CXS Explosion 01. If I click that, I can then click this magnifying glass and see where it is. So it's in the Niagara examples, and it's from the explosion. So I'm actually just going to duplicate this, save myself some time. I'm going to call it CS for camera shake, cannon fire 01. I'm going to open it up. And this is the data that actually affects how the shake looks. Okay? I encourage you to play with this and figure out what feels best for you. I'm just going to put in some numbers in the interest of time. So 10 for the amplitude, how big of a location change we want. 3 for the frequency, how many times per second we want that spike to happen. And then 3 and 8 for the rotation, and I've just tweaked some values in here. Now when you go back in to your pawn, click here, you should see that one we just made, CS Cannon Fire 01. We just need to change the settings here. So epicenter is simply where we want the shake to happen. So we're going to go get actor location. This is just going to get this actor's location. It's going to start at 0, and we're just going to make it end at 1,000 meters and orient shake towards epicenter. Now there's other nodes we could use. We could apply the shake directly to this camera, but by using a node like this, we can then have this character spawn a shake that can affect other characters. So if we decide, hey, we want this to be a NPC in our game or an AI, the shake can still affect another character's camera. So compile and save, and now play. And you'll see when I shoot, I get that one big rock back motion. So now we have our barrel pulling back, we have the physics affecting the rig, we have a muzzle flash, and we have some camera shake going. All right, so the next step we're going to do is to create the actual projectile and have it shoot out of the cannon and explode in our environment. So to do that, we're going to go over to our blueprints. So I'm going to right click, blueprint class, actor, BP underscore shell, projectile, open that one up. Let's add a sphere collision. This is going to be the collision for our projectile. I'm going to add a static mesh and assign it to be the shell from the Niagara effects. I'm just going to make it a bit bigger. And I'm going to go in and say no collision for this. It's going to be handled by the sphere. And the last thing I need is a way to move this. So if I search for projectile, I can find the projectile movement component. It's built exactly for this. I'm going to select that, and all I'm going to change is set the initial speed to 10,000. Then I'm going to go to the event graph. I'm going to remove these events, select my projectile, and come down. And I want, when the projectile stops, to trigger something then. So I'm going to add an event here. So when it stops, that's when I want to spawn system at location. And the location is simply going to be get actor location, the same location as the projectile. For what we want to spawn, if we search for explosion, there's a few to choose from. Let's go with ns underscore explosion. Compile and save. Now we need to spawn the projectile itself. So in our pawn, we're going to go to our function we've already made, and we're going to spawn actor from class. Search for our projectile. Make sure we add the right one, BP shell projectile. Then all we need to do is make sure it's facing the right direction, and then the projectile movement component will handle the rest. So for the spawn transform, I'm going to split this. I'm going to get my skeletal mesh. I'm going to get bone transform. And I'm looking for that Canon 03 bone. If you remember that one that we put the muzzle flash on. And I'm just going to plug in the rotation and location. We can also plug in the owner and instigator, but we won't be using them in this tutorial. For this to work, we're going to need a bigger level. So let's go File, New Level, Open World. Create that. Then File, Save Current Level As, Maps, Open World Test. All right, we need to go to World Settings and apply our game mode, Mech. And with the way that we've set this up, we just need to make sure that the player start here is set to 0 rotation. And when we click play, we can see that it's not actually colliding with the ground. So let's go back and figure out why. First, we want to change rotation follows velocity so we can get the shell facing the correct direction. Then I'm going to go to my sphere, and if I scroll down, I can see it's set to overlap all dynamic. So instead, I'm going to change it to, and we just want to change our shell to rotate like this. Let's get it right in the settings. And I'm just going to make it a little bit smaller. Okay, it's working, but you can see that the explosions are really small. So I'm going to show you how to do it really quickly. We're not going to go into Niagara. It's too in-depth for this tutorial. I'm going to duplicate the explosion we want. And then I'm just going to call it cannon explosion so I know which one it is. I'm going to open that one up. Okay, and we can see all the different emitters that are occurring. We can go here and we can change the sprite size min and max. I'm just going to multiply them by 5. All right, and that should be good enough for what we're after. Now we just have to make sure that on our projectile, we're spawning our new explosion. So if I search cannon explosion, now when we click play, we've got a better sized explosion going. I'm going to go in and lower the force a little bit so we're not shooting quite as far. And I also want to just add a trail to our shell so it's a bit easier to see. So I'm going to go in, add Niagara particle system, and I'm just going to use one of the existing ones here, the rocket trail. So now you have a little something showing where the shell is. And one last thing I want to do is I just want to add some camera shake for when those explosions happen. But I don't want it to just be happening instantly, where I'm shooting really far away, waiting 10 seconds, and then bang, and then it instantly hits me. I want that delay and that feeling of power and distance. So to do that, I'm going to have to do a few different things. Firstly, I'm going to have to go into my camera shake folder. So you'll find that Niagara examples, FX explosions, camera shake. We can see the one we made before. I'm going to duplicate the one we made before and just call this cannon explosion. And for this one, I want more vibration feeling. I want like a smaller amplitude, but with more frequency, like the ground is shaking, a bit like an earthquake. So I'm going to go lower amplitude, higher frequency, again, lower amplitude, higher frequency, and I want to change the timing. So the timing is actually quite low, 0.25 here, quarter of a second for the shake. I'm just going to change that to 2 with a 0.3 blend in time, 0.3 seconds of coming up, and 1.6 seconds of going out. So it comes in quite quickly and then fades out. While I'm here, I'm also going to just change my cannon fire because I forgot to change the timing on that. For the cannon fire, I want probably something like 1.1, and again, like a longer bleed out time. All right, then I need to go back into my projectile, and like I said, I want the camera shake to spawn here, but I want it to spawn after a delay. So I'm going to go here, play world camera shake, choose this cannon explosion one I've made. I'm going to use the current location of the projectile. And I'm going to set the outer radius to really large so we make sure we feel it, but with a decent size fall off and orient shake towards epicenter. Okay, but if I just click this now, you'll see what I mean about that delay being needed. So it's kind of fine when it's up close, but when it's that far away and it's just instantly happening, it feels a bit weak, like the distance doesn't matter. So we're going to add that delay. And the way we're going to do that is by adding begin play. We're going to get the time in seconds. And this is just the current simulation time since the game was brought up to play. And we're just going to store this. And this is our spawn time of this particular projectile. So when it's first spawned, it runs this. And when it stops, it's going to go here. And we're going to get the time in seconds again. But we're going to subtract the spawn time. And this will just give us exactly how long it's been since it was first spawned. So how long it took to reach its target, essentially. And then I'm going to add a delay. And I just want to multiply this number by 0.5, so half of it, and use that as the delay. Let's see how that looks. So now you really get that feeling of grand scale, right? This is a huge mech and it's shooting across huge distances. So that explosion takes a while for the shockwave to reach us. And that's where we're going to leave it. There's so many settings we've been over that you can tweak and play with, and you can apply these principles that you've learned here to any character mesh you want and really create anything you want, whether it's for animation, for film, or for games. I'm going to provide the documentation below that links to much more in-depth details about some of these systems and settings. I encourage you to experiment and create some cool stuff. Let me know if this tutorial was helpful or if there's anything I can improve for the next one. Thanks and good luck.